Alright, hey, we're gonna just talk about example B here, and in the investigation he wrote number sequences in table columns. Remember that you can also display sequences as a list of numbers like this, 1, 3, 5, 7. So you can write them in the table in a column, you can write them in rows, you can write with commas. There's all sorts of different ways you can represent numbers and sequences. So each number in the sequence is called blank, and the 3 periods indicate the numbers continue. So what is that blank? What are they called? They're called each term. Each number in the sequence is called a term. And the 3 periods indicate the numbers continue. So we just know that this continues on for a very long time. Okay, so this says find the missing values in each sequence. We really want to find this term, and this term, and this term. Okay, so I look at this, say 7, 12, 17. I know that this is going up, so I either need to say it's going to be adding or multiplying by a number bigger than 1. So I'm going to say 7. First I'm going to try adding. 7 plus 5 is 12. 12 plus 5 is 17. Well, that seems like a pretty good answer, so that means I should be able to add 5 every single time. So example A, I'm going to start at 7. I'm going to add 5. So 7 plus 5 is 12, plus 5 is 17, and that should be 22. And then I get 27, and then I get 32, and 37, 42, and 47, and 52. So there's the first one. And then part B, 5, 1, negative 3, and it's going down, so I either need to say it's subtracting or probably dividing. But let's see. If I go 5 to 1, that's minus 4. 1 minus 4 is negative 3. So I know part B, I'm going to start at 5. And I'm going to subtract 4. That seems to work. 5 minus 4, so negative 3 minus 4 is negative 7. And negative 7 minus 4 is negative 11. Negative 11 minus 4 is negative 15. What you could do is instead of trying to subtract, I could just add and keep the negative in front. So that should be 15 plus 4 is negative 19. And 19 plus 4 is negative 23. And negative 27 plus 4 would be negative 31. There you go. So now we have negative 7, blank, negative 29, negative 51, negative 62, negative 84. So I know that these are going down, so it means either I'm subtracting or I'm adding. And I'm going to use these two to see if that kind of works out. So how do I go from negative 51 to negative 62? I'm going to say I think that it's going to be subtract 11. So let's see if that works. Negative 7 minus 11 would be negative 18. So let's see if this works. Negative 18. And then subtract 11 is negative 29. Subtract 11 is negative 40. And then negative 51, negative 62, negative 73, negative 84, and negative 95. So that works. So we're going to start at negative 7. And we don't really have to write all this down. I'm just trying to write it as a recursive sequence. So start at negative 7. All right, and then part D. 2, negative 4, positive 8, negative 16. So that means I'm going positive to a negative to a positive to a negative to a positive. It looks like the sign is switching every time, which means I'm probably multiplying by negative 1 at least to make sure that sign switches. And if they were all positive, 2 times what is 4? Well, that's times 2. 4 times 2 is 8. Times 2 is negative 16. Okay, so it means I'm going to be multiplying by 2. But I really want to multiply by negative 2, and I want to start at 2. Let's see if that works. Start at 2 and multiply by negative 2. 2 times negative 2 is negative 4. Negative 4 times negative 2 is positive 8. Positive 8 times negative 2 is negative 16. All right, so this should be negative 64, 128, negative 256, 512, and the last one, I don't have room to write in there, is 1024. So there you go. There are some different ways of looking at and being able to write patterns.